Hello everyone, this is Aisha Parika. I'm currently studying in Sri Venkateswara College of Engineering, and the topic for today's video is system call and is a small concept, and the subject or the course operating system. Let us begin with the video. Okay, so introduction to system calls. System calls are a fundamental part of operating system, serving as the interface between the user, programs, and the kernel, providing a way for application to access the system's resources and functionalities. Definition and purpose of system call. There are mainly four important purposes of system call, that is resource allocation, process management, security enforcement, device access. So let us first know the definition of system calls. System calls are requests made by the program running in the user space to the OS kernel to perform privileged operations. They bridge the gap between the user level processes and the operating system's core functionalities, providing a structured and secure way for applications to access and interact with system resources. The purposes of system calls, let us know all the four of those one by one. First one is resource allocation. System calls enable programs to request and manage resources such as memory files and network connections. Process management. System calls are used for creating, terminating, and managing processes, including scheduling, synchronization, and communication between process. Security enforcement. System calls are essential for enforcing security policies and protecting the system from unauthorized access and malicious activity. Device access. System calls provide a standardized way for programs to interact with hardware devices such as storage drives, network interfaces, and input output properties. Types of system calls. There are basically five types of system calls. Those are file system management, process management, device management, communication, and security. Basically, system calls are categorized based on their functionalities they offer. Let us know the process management, file system management, and device management. Process management includes create process, terminate process, wait for process, get process ID, and set priority. File system management includes open file, close file, read, write, and seek file position. Device management includes read device, write device, control device, allocate device, and deallocate device. System call interface. The system call interface provides a well-defined set of functions that applications can use to provoke system calls. The interface is typically implemented as a library, providing a consistent, portable way for programs to interact with the OS. There are three parts of this system call interface. First one is user program. A program running in user space makes a request for the system call. The system call library, the library provides a wrapper function that translates this program's request into a system call. Kernel receives the system call request and processes it, performing the necessary actions. System call execution process. When a program initiates a system call, the execution flow transitions from user space to kernel space. The system call is then processed by the kernel, potentially involving interactions with hardware resources before the kernel returns control to the user program. There are four steps in the execution process. User program request. A user program issues a request to the system, requests a system call request through the system call library. Context switch. The operating system switches from the user's program's context to the kernel's context. Kernel processing. The kernel executes the system call performing the required actions. Return to user space. The kernel returns control to the user program, potentially giving the error statement or the required result. System call parameters and return values. System call typically involves parameters passed from the user program to the kernel, specifying the arguments for the desired operations. Upon completion, the kernel returns a value to the user program, indicating the success or failure of the operation and potentially including an relevant result. The basic parameter types used are mentioned here with their description. Those includes descriptor, that is an identifier of an open file; memory address, the location of data in memory; memory address; process ID, the unique identifier of the process; string textual data; and integer is the numerical value. System call error handling. System calls can encounter errors during execution. Error handling is crucial for ensuring application robustness and preventing unexpected behavior. The kernel typically returns an error code to the user program, which can then handle the error appropriately. Invalid arguments, incorrect or invalid parameter values passed to the system call, and permission denied, insufficient permissions to access a resource or perform an operation. File not found, it is the specified value, sorry, the specified file does not exist on the file system. Network error, an error occurred during network communication or connection. These four are the basic errors found in the system call. Kernel user mode transition. When a system call is made, the processor switches from user mode to kernel mode. This transition grants the kernel privileged access to system resources and allows it to execute operations that are strictly in user mode. After completion, the system call, the processor switches back to user mode, returning control to the user program. User mode is where the program runs in user mode, restricting from directly accessing hardware or critical system resources. Kernel mode operates in kernel mode with full access to system resources and privileged instructions. Mode switch, a system call initiates a mode switch, transitioning the processor from user mode to kernel mode. Common examples of system calls. System calls include file output input operations, process management functions, and system information queries. These calls provide basic functionalities for interacting with the operating system and managing resources. So file system call includes open, close, read, write, seek, and delete. Process management call includes create, terminate, wait, signal, fork, or X. Network calls include socket, connect, send, receive, bind, and listen. Importance of system calls in OS. System calls are essential for operating systems, serving as the foundation for user kernel interaction and providing a secure and structured way for applications to access system resources. They ensure system integrity, enable efficient resource management, and provide a consistent interface for application developers. These are the the mentioned four are the important concepts of the system call in OS, that is security, portability, efficiency, and abstraction. So this is the end of our video for today. I hope you guys felt the video was useful. If you felt the video was useful, please do like, share, and subscribe.